So essentially our capping area will include both the pink and the blue lines, and will encompass both PCB and mercury contamination.
Sean?
Yeah.
If you don't mind, can I go back to that slide?
Absolutely.
Okay, so when you're looking at the pink line, which is your higher concentration, and the blue, which is some of the PCPs, why wouldn't you just go like kind of like straight out, straight across, straight in, and straight back?
Well, keep in mind that these lines are based on ecological risk assessment, so they had to put a line in the map somewhere. Typically what we see though, when you have contractors come out on site and start to implement this cap, they're not going to look at these lines that finely. I mean, they'll essentially do what you talked about. They'll put a block around and say, well, we're going out and we're not talking about surgery here. We're talking about backhoes laying in sediment for barges. So it's not like they're going to trace that line out. So they essentially put a block around those areas, and essentially what we'll get is probably overcapping beyond those boundary areas, which is also a very good idea too, right? It's a bit of a conservative approach. But as I said, you know, we're not talking about a fine process. It's heavy equipment and laying material down from a barge. So that's how they'll approach it as well. Sorry, you had a question?
This 15-centimeter layer of clean sand that you're going to drop down, does your study show that the wave action is going to eventually take it away, or is this just going to stay in place?
Well, there will be some movement of the cap, and you know we're quite aware that 15 centimeters. That's how we define a thin layer cap. It's not meant to be a containment or a cutoff cap in terms of the contaminant. We expect some movement of the material, but we expect it to cover most of those contaminated areas. And really the approach that's been taken with this design is that we're looking at the area in its entirety. And, we're looking at it from a risk-based perspective. And could this project proceed without doing anything on the site? Well, sure it could. And if you wanted to wait another 25, 30, 40 years for that natural sedimentation to occur. But the intent is to enhance that process and to, I guess, improve the timeline so that we can delist the area quicker. The idea with the cap is that we'll put it down and we'll monitor it over a number of years and see if it does. We expect some erosion and some movement, but the intent is that it maintains its integrity over the bulk of the site. That's probably sufficient. That's going to probably lower the risk sufficiently that we can still continue with delisting the site. Now, if the monitoring program, 10 years down the road shows that a lot of that site has been exposed, then yeah, we're going to have to go back and look at whether we need to recap or supplement that cap to cover up those exposed areas. But we do expect some areas to be exposed and some that cap to be moved around.
Where are you getting this capping material?
Well, that'll be up to the contractor. Once the tender contracts are awarded, they'll have to source materials. Now, we've done a little bit of preliminary work ourselves to look at local availability of that material, and there is material that we think will meet our specifications for capping material. And David will probably talk about this a little bit later, but the source of that material is available locally. So now we haven't quantified it, we haven't specified where it should come from. We've just confirmed that the material that we think will work best for this cap is available locally. Now it'll be up to the contractor to source that material, to quantify it, and arrange for it to be supplied to the site. And that will happen as we get into the tendering period in the spring. Because we're not going to go out and say, well, you have to use this pit or that location. That'll be up to the contractor to find those locations that meet the specs for the capping material, but also provide the best pricing in terms of transportation of materials and sourcing of materials. David will probably touch on that a little bit more when we get into the design and the specifications later in the presentation.
It's a good question. That's clearly always one of your design considerations, that you wouldn't want to spec a material that arguably has strong technical parameters, but that you just couldn't find it here, and you balloon the cost by having to bring it in from somewhere else. So to the extent that you can meet your objectives by speccing a material that can be sourced locally, then that's advantageous to the